All right, for 12.2, number 29, you've got the problem x squared minus bx plus c equals 0. And you're asked to solve this for x in terms of a, b, and c. There's no a, so just in terms of b and c. And we're going to use completing the square. So when we use completing the square, we always start by isolating, making sure we have a coefficient of 1 on the x squared, which we already have. And then doing the x squared and the x on one side and then the constant on the other side. And then our procedure is to take half of the middle term. So half of b is just 1/2 times negative b, which is negative b over 2. And then squared is going to give you b squared over 4, right? Negative b over 2 times negative b over 2 equals b squared over 4. So we need to add that to both sides. And so it should be negative b squared over 4, not 4 squared over 4. The left side factors, and remember, the way that we always can factor this is by whatever half that middle term is, that's how this perfect square factors. It works the same way every time. So it gives you x minus b over 2 squared equals, and then this side, I'm going to go ahead and put these together. And so negative c would be the same as negative 4c over 4. And so that's going to give me b squared minus 4c all over 4. I'm then going to take the square root of both sides, and that's going to give me x minus b over 2 equals plus or minus, because you add the square root, so you need to put the plus or minus. The numerator, we don't know what the square root of that is, and so we're just going to leave it as b squared minus 4c. But the denominator, the square root of 4 is just 2. So now when I solve for x, I add b over 2 to both sides, and that gives me x equals, well, common denominator of 2, so it's going to be b plus or minus square root of b squared minus 4c all over 2. And so that is the solution in terms of b and c for x.